Hello everyone. Today we are going to perform an experiment of data mining and analytics. So in this experiment we are going to implement algorithms for the following questions using any programming language of your choice. But today I am going to use C++ for implementing these questions. So what is the question we have? The question is we have to prepare a data set by accepting age data from the monitor. The age data are integer values representing age of people belonging to the different groups of the society with age from 5 to 95 years. We have to take 50 such age data values, and this question is from question number 2.2 on page number 80 of handbook. So first of all, we have to prepare a data set containing 50 data values. And then the first question in this is we have to arrange the data in ascending order. Then we have to compute mean, median, and mode of the data. So what is mean, median, and mode? Basically, mean is the average of all the data, which is given by sum of all values upon total number of values. And median is the middle value of the data after arranging it in an order, either ascending or descending. So middle value is calculated uh, using two methods based on the value of n, whether it is odd or even. If n is odd, that is number of values present in the data set is odd, then we can directly find the middle value, that is median, by finding its position using n plus 1 by 2, which is the index of the data of the median in the data set. And if n is even, that it can be found by using the average, by taking the average of two middlemost values, that is the data value at index n by 2 and data value at index n by 2 plus 1. And what is mode? Mode is the most common value, that is the data value having highest frequency in the data set. It can be unimodal based on the number of frequency of the data of a particular data value in a data set. Data set can be unimodal or multimodal. If multiple data values has same frequency, which is also the highest frequency in the data set. The next question is what compute percentile of a data item from the data set. So what is percentile? Percentile. What is percentile? Mostly we can define percentile as a number where a certain percentage of scores fall below that given number. Percentile and percentage are often confused, but both are different concepts. The percentage is used to express fractions of a whole, while percentiles are value below which a certain percentage of the data in a data set is found. If you want to know where you stand compared to the rest of the ground, you need a statistics that report relative standing, and that statistics is called percentile. For example, you are the fourth tallest person in a group of 20.80% of people who are shorter than you. That means you are the 80th percentile. If your height is 5.4 inch, then 5.4 inch is the 80th percentile height in that group. Percentile formula is given by this. Percentile is equal to n by n across 100, where n is the ordinal rank of a given value, where capital N represents the number of values in the data set, and P is for percentile. The other formula for percentile is given by this, which is P is equal to number of values below X. X is the certain value for which we are finding percentile, uh, um, divided by total number of values in the data set multiplied by 100. This is the percentile formula. What if we want to calculate the kth percentile for a data set? So the procedure we have to follow for finding kth percentile for a data set are as given. The kth percentile is a value in a data set that divides the data into two parts. The lower part contains k% of the data and the upper part contains the rest of the data. The following are the steps to calculate the kth percentile, where k is any number between 0 to and 100. Step 1. Arrange all data values in the dataset in ascending order. Step 2. Count the number of values in the dataset where it is represented as n. Step 3. Calculate the value of k by 100 where k is equal to any number of between 0 and 100. Step 4. Multiply k% by n. The resultant number is called an index. If the resultant index is not a whole number, then round to the nearest whole number, then go to step 7. If the index is a whole number, then go to step 6. The step 6, it is for when the resultant index is a whole number. We have to count the values of in our data set from left to right until you reach the number. Then find the mean for that corresponding number and the next number. The resultant value is the kth percentile of your dataset. Step 7. When the resultant index is not a whole number, then count the values in your dataset from left to right until you reach the number. The obtained value will be the kth percentile in your dataset. The next question, we have to compute 70 and 80 percentiles. And then we have to calculate 17th and 80th percentiles. We have to compute mid-range of the data. Mid-range is given by the average of minimum and maximum value present in the dataset. Now, what is the next question? The next question is compute first and third quartiles of the dataset. So, what are quartiles? So, basic quartiles. What are quartiles? Quartiles are the set of values that divide the data points into four identical values using three individual data points. Quartiles are the values from the dataset which divide the dataset into four equal parts where each part of the dataset contains an equal number of observations. There are three quartiles in total, such as first or lower quartile, second quartile or median, third quartile or upper quartile. So quartile can be visualized as this. Suppose this graph shows the overall data set arranged in an order. So Q1 is this data point, which is which is also the 25th percentile of the data set. Q1 is the first quartile or lower quartile. 25% of the data set are below it. Q2 represents the median or the middle term, and Q3 is the 75th percentile, or say a data point which is at 75th percentile, for which percentile is 75. Quartile formula. In order to calculate the data points which divides the data set into four equal parts, that is Q1, Q2 and Q3, the formula we use is for Q1, which is given by n plus 1, where n is the total number of terms in the data set plus 1 divided by 4. This gives the index for the first data point for which is the first quartile of the data set. Q3 Q3 can be calculated as the 3 by 4th of n plus 1th term. This gives the index for the data point which is third quartile. And Q2 is basically median, equivalent to median given by difference of Q3 minus Q2, or it is the middle term for the data set. It can also be visualized using this graph. On x-axis we have independent variables and on y-axis we have continuous variables. So first quartile lies on this data point. This is almost the 25% of the data. Then second quartile lies at this data point, and the third quartile lies at this data point. This divides the overall data set into four parts. These two questions are for the same operations, and the last question that we have to perform is we have to give 5 number summary. 5 number summary refers to minimum, maximum, first quartile, third quartile, and median value. So let's implement these questions using C++. So first of all, as we have to calculate, first of all we have to generate a data set, right? So for generating a data set, we are first of all defining a data set, um, de- defining a vector of int type called data, and we are defining a function generate data and passing 50 as parameter for generating random data values for the data set. So for generating data values, this function is used. Here we are defining a vector data and using this function ran function for generating random number between 5 to 95 and pushing the generated data value into the vector data, and this function returns the vector data, and after generating the random data, this is the data set we get. Now for the next question, as we have to next operation that we have to perform is arranging the data in ascending order. So for arranging the data in ascending order, this is the function we are using, and this in C++ we can directly sort the data in ascending order using sort function, and this function takes vector data as parameter and returns the vector data as output after arranging it in order. The result we get after arranging the data set into an ascending order is this is the output we get. The next question we had to operation that we had to perform are computing mean, median, and mode of the data. So for computing the mean, this is the function we are using, and which takes data as a parameter, and then we are returning the mean value. And for this, we are using accumulate function, which is inbuilt function, which sums up all the data set values together and then divided by the size and data set size, which is 50. So the mean value we get is 47.06 as output. The next operation we had to perform was a median. So for computing the median value, we have to first of all decide what is the data set size. If it is even, then the median value will can be different, and if it is odd, it, it can have different value. So here n is defined, which takes the data set size, which is 50 for this experiment. Now this if a statement checks whether the value of n is even or odd. Since the value of n is even, so this returns the average of the data value, two middlemost values. As this is a vector and the index of the vector starts from 0 to n minus 1, so the two middlemost value will be at index n by 2 minus 1 and at index n by 2. And then after taking the average, it returns the data value. The median value we get after calculating is 42. Now for calculating the mode, which is the data value with the highest frequency in the dataset. As we can see, the dataset has maximum frequency of 3, 4, 6, 21 and 41 as well as 42. So the first value with highest frequency we get is 6. So the value of mode is 6. Here we are defining a map frequency. This maps this map frequency includes maps the data values with their frequency in the data set. And then we are using we are giving mode is equal to data value at the first index, that is 6. So at first we are giving mode value is equal to 6 and max count is given as the frequency of 6, that is 3. Now this for loop checks whether the max count value of 6 is highest or not. If it is the highest, then it gives the value of mode as 6, and if it is not, then it changes the value to then it the max value changes to for the other and returns mode value which is 6. Now we have the next question we have to perform is computing percentile of a item from the form dataset. So as we have to perform percentile of a data item from this data set. So let's see what is the percentile that we have for 35. Let's see what is the percentile of 35 in the data which is present here. So the percentile value we get for data item 35 is 36%, which means 36% of the data are below are smaller than or less than 35, which is these data values are smaller than 35 or equal to 35. For computing this percentile of a particular data item, first of all we are sorting the data in ascending order, then finding the data value for which we have to find the percentile in the data set. using find function, and then we are finding the index of the data item in the data set. If it is not present in the data set at all, then it returns -1. And if the position of the data set is present, then percentile is given by position of the data item plus 1 divided by size of the data set multiplied by 100, and then it returns the percentile, which is 36% as that the output we get. The next question we have to the next question we have is computing 17th and 18th percentile. These two questions are similar. So for computing percentile of for computing percentile of the data set of a kth percentile, this is the function we are using. This takes the index. Uh, we are using seal function for calculating the index of the kth percentile value. So percentile value, which is 17th and 18th percentile. This function takes data set and percentile as a parameter, and then calculates the index first and returns the data at index calculated. The 17th percentile we get is 70, which is at this position, and 18th percentile we get is 73, which is at 73 on this position. So what is the meaning of 17th and 18th percentile? This means for 70th percentile there are 70% of data which are either smaller than 70 or equal to 70. That means these data values are smaller than 70 or equal to 70. And 80th percentile refers to 80% of the data are smaller than 73, which means these values. Now what we have to implement, we have to compute mid-range of the data. So mid-range was the average of minimum and maximum value of the data set. So for computing mid-range, we have this function which takes data set as a parameter and returns average value. Data at front and data at back are added together and divided by 2, which gives the mid-range. The mid-range we get here is 50.5, as 6 was the minimum value and 95 was the maximum value. Now next question that we have to implement is we have to compute first and third quartiles of the data set. So first, for calculating the first and third quartile of the data, we are using this function. This takes data set as a parameter, and first in is defined, which takes data set size, which is 50, and we are defining two variables q1 and q3, which are first and third quartiles. For calculating first quartile, which is also known as lower half quartile. So we are taking the data set from, we are defining a vector containing data set from the beginning to the index from the beginning to beginning to plus data set size divided by 2 means half of data size. So this value is 6 plus 25, which is 31. The first quartile contains data 6 from 30 below 31, which is this values. And then we are computing median of these all values to give first quartile. The first quartile here we get is 21, which is nearly the median value. Now, now for third quartile, similarly we are computing median for the third half, which is from end of the data to 25% of from data of the from the end. So after computing median for third quartile, we get 73 as the value. So first quartile and third quartile we get is 21 and 73. Now next question that we have to implement is give 5 number summary of the data. So for giving 5 number summary, 5 number summary refers to minimum, maximum, first quartile, third quartile and median value. So we are using this function for it, which directly prints the minimum value, which is 6, first quartile, which is 21, that we have calculated earlier, median value, which is 41, 42, third quartile value, which is 73, and maximum value, which is 95. So this concludes our first experiment for data mining and analytics.